Hello dear students, today we are going to discuss about one of the most important concept in mechanics is nothing but triangular law of vector addition. So many of you may be knowing triangular law of vector addition, but how many of you know the physical implication, the application of vector addition, triangular law of vector addition? Today with a simple example, I will show you the meaning of triangular law of vector addition. Assume that you have a block and some forces are acting on the block. At this point, some force A Newton is acting, okay? This is A Newton and one more force is acting at the same point, which is B Newton, okay? Which are of different magnitudes, B Newton. If you want to find out the net force or resultant force acting on this body, we can do the vector summation, but we cannot do the normal algebraic summation. What do you mean by that? So the sum of this force, the F net is not equal to magnitude of A and magnitude of B. The summation of magnitude of A and magnitude of B, if you are taking, you will not get F net because is acting in a different direction. If they are acting in a same line, in the same direction, we can just add the magnitudes, you will get the resultant vector or resultant force. Here, the resultant force we can obtain. See, F net is equal to vector A plus vector B. This is how you have to find out. So, what is the meaning of this? How to find out? How to find out a method to find out resultant from this A and B graphically, that you have to understand. That is the logic behind triangular law of vector addition. In order to explain that, I will show these vectors in a little more rigorous way by showing in a coordinate system so that you will get exact idea of what we are discussing. We have a proper Cartesian system here and I am going to show all the vectors in this plane. Assume that the first vector, the A vector is this much. You can see the magnitude 15.8 and 18.4 degree with the x-axis. So we don't need that now, but it's the first vector. Assume that is 15.8 Newton is acting in that direction. The next vector, the B vector is acting at the same point and some other magnitude. Maybe we can say 11.2 Newton, okay? And 63.4 degree with x-axis that is making. I hope you understood the angle part. See this idea. So this is like 18 degree and 63.4 degree. Fine. Now, see here, we can always do one. We can shift this vector parallelly. That means there are certain vector called free vectors. Free vectors means, for the purpose of calculation, we can shift parallelly those vectors. So such vectors are known as free vectors. Force, in this situation, the force is a free vector. It's not always applicable. In rotation motion, that is not applicable. We'll see that later. See, if you are shifting this vector parallelly, that means I can keep like this. That means, see, for the A vector, this arrow part is known as head of the vector. This is known as tail of the vector. So what I am doing here, see, the second vector, the tail of the second vector, I am connecting to the head of the first vector. So I am just arranging like this. Fine. If that is the case, how to find out the resultant force? Resultant force we can find out by taking the component of this force. The component of this force means, that here if A I am taking, you have components here. This is a component, this is the x component, AX. This is x component of A. Similarly, this is AY and for B again we can say this is BX and this is BY. Fine. So these are the components of A and B respectively. We can always add the components because component of AX and component AX and component BX are in the same direction, x direction. We can add them together. That means you can add AX plus BX. That is going to be the net force acting in the x direction. Similarly, AY and BY we can add together so that the net force acting in the y direction we can find out. So that is the logic. So if you have AX plus BX as the base of a triangle and height AY plus BY, then you can apply Pythagoras theorem and you can find out the hypotenuse or the resultant. That is the logic here. Fine. Look here. I will show you the resultant now. So if I show the resultant, see here the sum of the vector is going to be this way. So, I am just some vector we obtained in this Cartesian. So, if I am shifting that vector, exactly you can see that the tail of that resultant is going to match with the tail of the first vector. The head of that resultant is going to match with the head of B vector. We are exactly getting this triangular law. Fine, what is the meaning? Now when I represent the components, you will get a better picture. Look here. See, you are getting a triangle with AX as base, BX as base here. See, see this bottom. What is that x-axis? You can see that is going to be, this is AX and BX. So, together we can say that AX plus BX. Similarly, the height of the triangle, we can say AY, BY. So, we can say together we can say AY plus BY. So, now we can say the hypotenuse is going to be equal to, how much is hypotenuse? Here, the hypotenuse of the triangle we can find out using Pythagoras theorem. Look here. See, up to here, some distance is there, AX and BX. This is AX, this is BX, and this is AY, and this is BY. So, together the length of the base is going to be AX plus BX, and this is going to be AY plus BY. Now, you know that as per Pythagoras theorem, we can connect this. And what is going to be the length of this side? If this is S, we can easily find out S. I hope all of you know that. See, no need to explain. In lower class itself, you studied. S is going to be equal to under root of, how much is the base? You can say AX plus BX the whole square, right? Plus AY plus BY the whole square. So, this is going to give you the magnitude of resultant force, exactly the value of S you can obtain. So, we can say S vector is going to be equal to A vector plus B vector. This is as per vector algebra. Fine. So, here is coming from the idea of components. If you are splitting into components, we can see how this is coming into picture. Fine. See, I hope all of you understood this. Now, the logic is, see, this is the resultant force direction. So, in such a situation, so if you are applying forces in that way, the first force is along this direction, second force along this direction, the resultant will be acting along this direction. That you can obtain by doing this math. Simple Pythagoras theorem, that's all. So, find out AX plus BX, then AY plus BY, then make a triangle, find out the hypotenuse. That length of hypotenuse is going to be exactly the resultant of the vector summation of A and B. That's the idea behind triangular law of vector addition. So, I'll brief in a second. Before going to concluding this video, I'll just quickly brief this. Assume that you have two vectors acting something like this. Is the first vector. What do you have to do? The second vector, tail of the second vector, you have to connect to the head of the first vector. So, in our case, this is A vector and this is B vector. Fine. How to find out the resultant? Resultant is simply drawing a line from the tail of the first vector to the head of the second vector. This is going to be the resultant vector, or in our case is S, okay, resultant vector S. So, we can say resultant vector S is going to be equal to A plus B, and including direction we can obtain. If you measure the angle from x-axis, you will get it. I hope all of you understood this.